Hello dear CMA aspirants from South India. As you all already know, Akash Agarwal Classes has launched for you all 100% English lectures in English for CMA Foundation students giving their examination in December 2025 and onwards. So here I am going to tell you how do you enroll in the batch. You just have to join our WhatsApp community which is given in the link. Fill up the Google form again given in the link and to download our mobile application Akash Agarwal Classes to access the notes. You all know the lectures which we are going to conduct will be 100% covered. There would be no subject which we are not taking care of. So we are going to take care of each and every subject, each and every concept. We are going to take MCQs for you. We are going to provide test papers. We are going to take live mentee sessions as well. Lectures which we are going to take for you all are 100% recorded lectures and not dubbed lectures. And you all know we have exclusive team ready for you all to teach you for your CMA Foundation December 2025 attempt for subject wise as well. And we are uploading the lectures on a weekly basis. All the important links which will be useful to you all are uploaded in the description box. Since we have many students who have cleared CMA examination at all the levels from Akash Agarwal Classes, and to reciprocate the love which we have received from South Indian students, we are here for you all taking lectures 100% in English, so that we can clear your CMA Foundation December 25 attempt together. So keep studying, do watch all the lectures till the end, and do show some love by liking the video, subscribing to the channel, and putting up a word in the comment box. Keep studying. Bye-bye.
Hello my dear students, yes, welcome back to another video, another lecture of your Maths English series. And in today's lecture, we are going to start with a new chapter. That is not a new chapter, but it is going to be a part of your chapter. We are starting a new topic today, that is regression from the chapter correlation and regression. We have already completed the correlation. We have already completed the MCQs of correlation, and today we are going to start with regression. So in today's chapter, we are going to study about what is going to be regression, what are the types, what are the ways by which we can solve the chapter over here, and what is the regression, what are the equations and everything that we need to study. So here, when I study about regression, everybody is going to write with me. And yes, if anybody of you is new to the channel, but do subscribe to the channel, because Akash Agarwal Classes is providing you with the lectures which are going to be recorded in English, and they are going to be in 100% English form. So yes, don't miss the lectures at any cost. Do share with all your friends who need or are in requirement of the lectures, the lectures which should be conducted in English. So yes, do share this with all your friends. And if you are new to the channel, do subscribe. Apart from that, we have created a WhatsApp community, an exclusive WhatsApp community for all the students, for all the South Indian students who want the lectures to be conducted in English. That WhatsApp community we are going to update many things, many important links, or any kind of video that we update, any kind of strategy that we update. The latest updates and the latest link is going to be provided on that WhatsApp group. So yes, do make it sure to join that WhatsApp community. Now let's start with the chapter regression. What do you mean by regression? Regression is going to be relationship between the variables. In regression, we are going to study about the relationship between the variable. Relationship between the variables. And now, when we study relationship between variables, there are going to be two variables, x and y. There are going to be two variables, x and y. So when we study about the two variables, x and y, we are going to study their equation. We are going to study about their what? Equation. So when I talk about the equation y on x, and next equation is going to be x on y. So your first equation is going to be y on x, and the next equation is going to be x on y. So we use y on x. What is y on x? What is x on y? You might be hearing it for the first time, but don't worry. first try to understand, first write down with me, let 15-20 minutes pass this lecture, make sure what I'm telling you, keep an eye on it, you listen it with properly, and then at the end of the lecture the things are going to become clear by a bit it are going to be cleared till the end of the lectures. So first, when we talk about x, y on x, so when I talk about regression equations, so these are what? These are equations. These are what? Regression equations. Y on x, I use y on x to find. We use y on x to find y. If I want to find y on x, if I want to find y on x, I am going to use y on x if I want to find y. I am going to use y on x if I am going to find y. If I use x on y, I am going to use x on y to find x. To find x. So if I want to find y, the equation that I will be using is y on x. If I want to find x, the equation that I am going to use is x on y. So here it becomes y minus y bar equals to byx. Now what is this byx? Byx is nothing but it is regression equation for your y on x. It is going to be regression equation for your y on x. The equation is going to be byx bracket x minus x bar. So this is going to be your first equation over here. Then when we are talking about x on y, the equation is going to be x minus x bar is equals to bxy into y minus y bar. So this is your first equation where we are going to talk about y on x, and when we talk about y on x, it is going to be y minus y bar equals to byx x minus x bar. The other is going to be x minus x bar is equals to bxy into y minus y bar. Then when we talk about that, I am going to teach you one more equation. The equation is y is going to be y is equals to a plus bx, where this b over here is nothing but byx. Similarly, when we talk about x on y, now I need to find y. Over here, I need to find what? I need to find x. So, I need to find x. That's why my equation is going to be x is equals to a plus by. And then this by is going to be what? bxy. So, when I want to find y, my equation is going to start with y is equals to. When I want to find x, my equation is going to start with x is equals to. Over here, when I talk about this equation, my y is going to be a dependent variable. My y is going to be a dependent variable, and when we talk about x, your x over here is going to be independent variable. Why is y dependent? Because this is my equation over here, and my y's value is going to depend upon whatever the x is going to be. If my x is 5, I am going to multiply it with byx, and that is going to be my y's value. But if my x's value changes, my y's value is automatically going to change. That's why y becomes an dependent variable, and x can be anything. It is not going to change due to anybody. That's the reason it is set to be x to be an independent variable. Similarly, in the scenario over here, x is going to be dependent and y is going to be independent. In both the cases, a comma b is going to be constant. A comma b are going to be what? Constants. And they are known to be, a and b are, they are known to be known as regression. They are said to be regression parameters. They are said to be what? They are said to be regression parameters. So you have to understand this thing. And one more thing you have to understand, in either first equation or second equation. Let me write down this equation over here. These are all the MCQ based points that can be asked. There are two regression equations. One, if you need to find y on x. Y on x is going to be, y on x is when I need to find y. And then I have given you two equations. Y minus y bar is equals to byx into x minus x bar. And the other equation is y is equals to a plus bx. When I want to find x, I am going to use x on y's equation. X on y's equation is what? X minus x bar is equals to bxy into y minus y bar. Or x is equals to a plus by. Over here y is going to be dependent, x is going to be independent in case of y on x. In case of x on y, x is going to be dependent and y is going to be independent. A and b are constants. They are said to be regression parameters. When I am talking about y is equals to a plus bx, when I am talking about y is equals to a plus bx, this a is said to be y's intercept. Y is said to be what? Y is said to be, sorry, A is said to be, just give a minute. There's some problem with my stylus. Y is said to be what? A is said to be y's intercept. B over here is said to be slope. B over here is said to be slope. Minus A upon B. I'll tell you this later on. Okay. So you have to understand A is what? A is going to be your y-intercept. B is going to be your slope. B. You have to understand this much thing for now. For now, there 98% of the students right now will be in some kind of confusion, some or other kind of confusion, that I am pretty sure. You don't have to worry, bacha log. As I've already told you, this is a basic thing. For now, you have to just understand. Yeah, in the regression chapter, we have to study all this kind of things: bxy, byx. There is slope, there is y-intercept. I need to find a. I need to find y for y. When I'm finding y, I need y on x. For finding x, I need x on y. So all this thing you have to just get an idea. Yes, we have to study this kind of stuff over here. Later on the line, when I'm giving you some examples, when I start solving some questions, at that time you are going to get a clarity. Till that time, there's going to be only a lot of confusion. So now let's see. We saw two things. One is x on y and one is y on x. So we saw regression coefficients. We saw regression coefficients. Now what is regression coefficient? Regression coefficient is nothing but two things that we saw: byx and bxy. These are your regression coefficient. Byx. When do we use byx? When I need to find y on x. It is very simple to remember. In byx, y comes first. That means y on x. In bxy, x comes first. That is x on y. So it is a way of keeping in mind. It is way of learning. When I'm talking about byx, y comes first. That's why it becomes y on x. In bxy, x comes first, that's why it becomes x on y. So when I'm talking about byx, my byx, you have to understand, byx becomes r. What do you mean by r? R means correlation. If you remember, r, covariance, r is going to be r into standard deviation of y upon, standard deviation of y upon standard deviation of x. Byx is going to be standard deviation of y upon standard deviation of x. Similarly, Vxy is going to be r into standard deviation of x upon standard deviation of y. So how to remember this formula? Again, very simple. In byx, y comes first, x comes later. So your standard deviation of y is going to be in the numerator and then standard deviation of x. But in case of bxy, x comes first and y then later on. So again it becomes what? Standard deviation of x is in the numerator's position and standard deviation of y is in the denominator's position. So this is your first formula for now. You have to keep in your mind. This is what? This is your regression coefficients, bxy and byx. Majority of the questions that are going to be asked in your exams are on the basis or on the base of your bxy and byx. That's the most important thing. So now one more formula for byx is going to be covariance of x comma y upon standard deviation of x square. Here for bxy, it is going to be covariance of x comma y upon standard deviation of y square. So this is going to be your bxy and byx. So now here we have seen two formulas for coefficient, regression of coefficient, bxy and byx. So byx is going to be what? R into standard deviation of y upon standard deviation of x. bxy is going to be r into standard deviation of x upon standard deviation of y. byx is going to be again covariance of x comma y upon summation standard deviation of x square. byx is going to be covariance of x comma y upon standard deviation of y square. So this is going to be your regression coefficients. Now, I think that we should solve some examples now so that you get a basic clarity, like how to solve the question, what type of questions they are asking. So let's see one question over here. Yeah. So you have to understand what type of question they are going to ask. The regression coefficient of y on x. See, when you talk about y on x, I have already explained you. Y on x, y comes first, so it becomes byx. Y comes first, x comes second. So byx, it is going to be byx of the following data. Then we see that x is to y is given. So let's make two columns over here. One column is going to be for x and then other column is going to be for y. We have to understand the regression coefficient. They are asking us what regression coefficient for byx. So if you remember, there were two formulas for regression coefficient of byx. That was r into standard deviation of y comes first, so standard deviation of y upon standard deviation of x. Or there was another formula, we could find covariance and then standard deviation of x square. Either of the things, whichever is easier for us, we can find out. So now let's see, I'll make two columns, that is x and y. They have given me x is 5, 2, 3, 4 and 1. Y is going to be 2, 3, 1, 5 and 4. Now I need to find byx. So byx, I am going to use the formula for covariance of x comma y upon standard deviations of x square. So I can easily find covariance. If you remember the formula for covariance, you must remember, but if the formula was what? The formula was 1 upon n summation of xy minus x bar into y bar. This was all. This was your covariance formula. So if you see here, I need x bar and y bar. So for that, I need summation of x, summation of y, and I also need xy. So I need x into y. So this is going to be 5 into 2, 10, 3 into 2, 6, 3 into 1, 3, 5 into 4, 20, 4 into 1, 4. And I also need x bar, x square. I need what? X square. So my x square over here is going to be, x square is going to be 5 square is 25, 2 square is 4, 3 square is 9, 4 square is 16, 1 square is 1. And now let's find x minus x bar, because for standard deviation, I need x minus x bar square. If you remember the formula for standard deviation, it was under root x minus x bar square upon n, if you remember. So let's find the summation first. Summation of x is what? 5 plus 2 plus 3 is 10, 14 and 15. Then over here as well, 5 plus 5 is 10, and then again summation of y is also 15. Both summation of x and summation of y is 15. Summation of xy, let's calculate summation of xy. This is going to be 20, 40, 43. And now this is going to be 9 and 1 is 10, 10, 10 and 16, 10. This is 20, 20, 30, 40, 45. It is going to be 55. Summation of x bar is 55. Now let's find x bar. Let's find x bar. X bar is going to be 15 upon, how many observations do we see? 5. So x bar is going to be 3. And y bar is going to be 15 upon 5. That is again going to be 3. So I got x bar and y bar. Now I need x minus x bar square. So my x bar is 3. So 5 minus 3 is going to be 2. 2 square is going to be 4. Then again 2 minus 3 is going to be 1. 1 square is 1. 3 minus 3 is going to be 0 and 0 square is 0. 4 minus 3 is again going to be 1 and 1 square is 1 again. 3 minus 1 is 2 and 2 square is 4. So now let's calculate 4 and 4, 8 plus 2, 10. This is going to be 10. Summation of x minus x bar. Now I need covariance. So I'll find covariance first. So covariance of x comma y is what? 1 upon n. That is 1 upon 5 into summation of xy is 43 minus x bar into y bar is 3. 3s are 9. So once I solve covariance, let me solve the covariance first. 43 minus 9 divided by 5 becomes my bad, 43 divided by 5 minus 9. So don't forget the board mass, first division. So this becomes minus 0.4. My covariance is what? My covariance is minus 0.4. Now I need standard deviations of x. My standard deviation of x is going to be under root summation x minus x bar square upon n. This is going to be x minus x bar is what? X minus x bar. Summation of x minus x bar is 10. So 10 upon n is 5. 10 upon 5, you solve 10 upon 5, it becomes 2. 2's root is 1.4142. 1.4142 is your standard deviation of x. Now let's solve b by x. My b by x is going to be covariance minus 0.4 upon, I need square of this. So if you solve, the square is going to be 2 itself. So I need standard deviation of x square, right? So I just solved 10 upon 5, 2, and then I took square root. Now I need it square itself. So it is going to be 2. So when I solve this, 0.4 divided by 2 is going to be 0.2. minus 0.2. So my byx is going to be 2. My byx is going to be minus 0.2 if you see over here. Option number A. Option number A, minus 0.2 is going to be your coefficient of y on x. So hopefully after a particular one, after one question, you might have got an idea like what type of question they are going to ask you, what are the probable chances, what are the types, what are the forms of question that they might ask you. Now let's see one more question. See, they have given us many things now, right now. They are asking regression coefficient of y on x. Sorry, x on y. So when they are talking about x on y, x should come first. That is going to be bxy then. And again, we know the formulas for bxy. It is going to be what? Covariance of x comma y upon y's square, standard deviation of y square, because y is in the later, y is coming in the second place. That means it is going to come in the denominator's place. So let's see what all the things that they have given us. They have given us summation of x, summation of y, summation of xy, summation of x square, summation of y square, and then n. Very easy. We can find everything we need. That's what we need. We need summation of, we want summation of byx. For byx, I need r into, I need, let's see, what are the things? No, they have not given us r, right? So I need the same formula. Covariance of x comma y upon standard deviation of y square. So how to find the covariance? Now we are well aware how to find the covariance. I'll just remove this formula. I'll keep it over here. So my covariance is x comma y is equals to 1 upon n, that is 1 upon 10, into summation of xy is going to be 800, and then we are going to multiply, see over here, here's the formula. Covariance of x comma y, 1 upon n into summation of xy into what? Minus x bar into y bar. But I don't have x bar, but I have 40 upon 10, that is going to be 4, and 20 upon 10, that is going to be 2. So this is going to be 4 into 2, that is 8. So let's solve this again. 800 divided by 10 into 8. They have given me summation of xy, right? I guess there might be some problem in summation of xy over here. Okay, now over here, what is the issue over here? We can find covariance of x comma y, but we cannot find standard deviations of x square because I don't have x minus x bar to solve over here. X minus x bar, I will need y minus y bar square because I need y square over here. So I don't have y and y minus bar, I don't have the data to solve this. So I cannot apply this formula over here. So at this time, we will need some other formula to solve bxy. So what are the other formulas if you see over here? See, I have given you two formulas that are the basic formulas. Byx is equals to r into standard deviation of y upon standard deviation of x. Then byx is equals to what? Covariance of x comma y upon standard deviations of x square. Then there are here three formulas which we use very rarely. These are the most two important formula that you don't have to forget at any cost. But apart from that, there is also a formula n into summation of xy minus summation of x into summation of y upon n into summation of x square minus summation of x the whole square. Again, if you see, x is in the later place, so that's the reason your x is always going to come in the denominator. Now, summation of bxy, it is going to be what? I'll write it over here. Everything in the numerator is going to be same. Minus summation of x into summation of y. Everything in the numerator place is going to be same. Only the denominator is going to change, and the denominator is going to be n into summation of y square minus summation of y the whole square, minus summation of y the whole square. So this is going to be what? This is going to be your formula. Only the denominator is going to change. Apart from that, there is more two formulas over here. You can take a screenshot, dx and dy. So what is dx and what not? We have already seen it in the your combined me the correlation regression chapter. In the correlation regression part, we have already studied. No. In the dispersion part. I'm so sorry. In the dispersion part. And here's another formula: summation of xy upon summation of x square, or summation of xy again upon summation of y square. This is also going to give you what? Bxy and byx. So let's see in my example over here now. Which was the example? This was second example, right? So the formula that we are going to use for summation of bxy is now going to be n into summation of xy, because we have all the data, minus n into minus summation of x into summation of y whole divided by n into what is in the next place? Y. So it is going to be n into summation of y square minus summation of y the whole square. N is 10. 10 into summation of xy is going to be 800, minus summation of x is 40. So this is going to be 40 into 20, 800. Again 10 into y square is what? 1500. Minus, I need y's whole square. So y's whole square is going to be 1500 summation of y's whole square. So where is summation of y? 20. So it is going to be 400. So let's solve this now. 800 into 10 minus 800 is going to be 7200 upon 1500 into 10 minus 400 is going to be 14,600. 7,200. This is going to be what? 0.493. So option number 0.493 is option number B. So we use the new formula over here for bxy and byx. If you see over here. Okay. So this is one type of question over here. Now if we see are there any, let's see example number 3. Example number 3 is again very easy. They have given us prices. They have given us price for X, amount demanded is quantity Y. So they have given us prices. They have given us price details and they have given us quantity detail also. So arithmetic mean. They have given us what? Arithmetic mean. So arithmetic mean is X bar. They have given us X bar 20. And then they have given us Y bar as well. Y bar is 55. Standard deviation. So they have given us standard deviation of X is 2. Standard deviation of Y is 5. So standard deviation of X is 2. Standard deviation of Y is 5. Correlation coefficient also they have given us, that is R. R is 0.6. So they are asking us Y on X. Y on X is always Y is going to come first. That means BYX. And now if you remember the formula is going to be R into standard deviation of Y upon standard deviation of X. So R is 0.6 into standard deviation of Y is, standard deviation of Y is 5. Standard deviation of X is 2. Now if you solve this, 5 divided by 2 into 0.6 is going to be 1.5. So your y on x is what? 1.5, option number C. So this is the formula that we have written in our table, and this is the easiest formula. This formula is going to be used only and only when we have r's value given. When they have given us the correlation coefficient, that is r's value that we have studied in the correlation chapter, that's when we can solve this formula, when I have r and when I have standard deviations. So at that time this is the easiest formula. Now again, example number 4 is a type of question that has the dx1 formula. So this type of questions are very rare to be asked. The formula is going to be, they are asking us x on y. So this type of questions are very rare to be asked. N into summation of dx into dy minus summation of dx into summation of dy upon n into summation of, this is going to be your dx square minus summation of dx the whole square. So they have given us majority things. If you see over here, this is x minus x bar, this is x minus x bar square, this is y minus y bar, y minus y bar square, this is x minus x bar into y minus y bar, and then they have given us n's value. So what here you can do is you can just directly substitute the given values and you can calculate this. So this is a type of question. Again, as I said, this type of question is very rare to be asked in your exams. It has been many years that this type of formula they don't ask us. So let's go to the next. The regression coefficient of y on x for the following. So that they are asking again regression equation. They have given us n's value, x bar's value, x value, summation of y's value, x minus x bar square, y minus y bar square. Summation of x minus x bar into y minus y bar is, they are asking us what? They are asking us y on x. So here we can solve it. Again, this is a sort of question. We have already solved it. Y on x, they have given us x bar, y bar 1 upon n. Yeah, we can use, here they are using the last formula. Here they are using the last formula, summation of xy. They are first calculating xy when x bar and y bar are a whole number. This can be used when x and x bar is what? X and x bar is going to be whole number only. So yeah, this is the formula. Let's find x bar first. X bar is going to be what? Summation of x upon n. N is how much? N is going to be 10. So this is going to be 25. Now what is going to be y bar? Y bar is going to be 210. 210 upon 10 is going to be 21. So x bar is 25, y bar is 21. And now I have x bar, I have y bar. Over here, what I can do is, they have given me 192. Okay, so if you see now, they have given us as if you have calculated that your x bar is 25 and your y bar is also 21. So if you see over here, they have given us x minus x bar. They have given us what? Summation of x minus x bar is 262. And if you see, x bar is similar to what we have calculated 25. Y minus y bar is as similar that we have calculated 21. So what I can do is I can write summation of x minus x bar. Right, summation of x minus x bar, that we can write it to be summation of x square, because here if you see in this formula, they have told us that x is going to be x minus x bar and y is going to be y minus y bar, where your x's and y are, x bar and y bar are going to be whole numbers. So if you see over here, we have calculated x bar and y bar, they are whole numbers, And here we can say that x minus x bar is going to be x. That's the reason I have written x minus x bar as x square. So they have given us x square is 262. Similarly, y minus y bar, y is the whole number, y bar is the whole number, we can write as y square. It is going to be 322. And similarly over here as well, this is x minus x bar, this is y minus y bar. We can write x minus x bar to be x and y minus y bar to be y. So summation of xy is 192. And now let's solve the question by our formula. We have summation of xy, we have x square, we have y square, we have everything that we need. So now summation of y square is going to be summation of xy upon summation of y the whole square. The summation of xy is 192 upon y square is going to be 322. So when we solve this is going to be 192 divided by 322. This is going to be our 0.59. 0.59627, something like that. So these were some of your questions. Now let's complete our table. We have written 2 formulas. Let's complete our other formulas as well. Let's write down the third formula. Third formula for your BYX. As I said, the only 2 formula that you need to keep in mind, don't forget these 2 formulas. We'll be writing other formulas as well, but these are the 2 formulas that we don't have to forget at any cost. These are the most important formulas. Then over here we can see summation of b by x and everything that they have given us. We have 3 formulas over here. So let's write down the other 3 formulas also. So we are going to write b by x first. B by x is, your formula was what? N into summation of xy, right? Minus summation of x into summation of y upon n into summation of x square minus summation of x the whole square. So if you see, this formula is very similar to what we do to find covariance. If you remember, it is very similar. Now the third formula is going to be bxy. Again everything is same in the numerator's place. N into summation of xy minus summation of x into summation of y upon n into summation of y square minus summation of y the whole square. This is your third. Now what was your fourth formula for b by x? That was for something dx. So n is same. You have to understand the formula. It is very easy to learn. See, n is going to be the same. Only your summation of xy is replaced with what? Summation of dx dy. So x is replaced with dx and y is replaced with dy. Minus summation of x becomes summations of dx. Summation of dy y becomes summation of dy. Again, n in the denominator is constant. Again, x square becomes dx square. This becomes summation of dx the whole square. So only your x is being replaced by dx. So it is not that much difficult to learn the formulas. Similarly, b by x is going to be n into summation of dx into dy minus summation of dx into summation of dy upon n into summation of dx square minus summation of dy square upon summation of dy the whole square. This is your what? Fourth formula. And the fifth formula, it is the most rarest that they are going to ask you question. But still, if you want to write it down, that is not, I won't suggest, but okay, if you want to write it down, we'll write it down, the fifth formula as well. So b by x is going to be summation of yx upon summation of x the whole square. bxy is going to be summation of xy upon summation of y square. We are going to use this formula only and only when we want x to be x minus x bar and y to be y minus y bar. And your x bar and y bar are whole numbers. So these are the fifth formula is the rarest of all. We are going to use which one is the most important formula for me? The first and the second. And if you still want, the third. So this is going to be your priority to learn the formulas. So we have seen many examples over here and the formulas as well. I left one question. Okay. This is the last question that we need to see over here, the regression coefficient of y on x. So they are asking y on x, that means we need vyx. So they have given us covariance, they have given us standard deviation of x, and they have given us standard deviation of y. Very, very, very easy. Byx is going to be what? R into standard deviation. I don't have R over here, right? Okay, so I have covariance, but covariance of x comma y upon standard deviation of, which is the last person over here, x. So this is going to be x square. Covariance is how much? Covariance is 121. And x square is 15 square. 15 square is, let's calculate now. It is going to be 121 divided by 225. 0.533. I'll write direct 225. Okay. This is going to be what? 0.53777. So I can write 54. Option number A. This type of questions are asked in your paper. This type of questions are asked in your paper where they'll be giving you R, they'll giving you standard deviation of x and y. You'll have to just substitute it. That's the reason I said many students are afraid. Like, see, many of the students right now might be thinking this chapter is so tough, that there are many difficult things. There are some things that is they're very confusing and many thoughts in your mind. But let me tell you, this chapter is one of the easiest chapter. The questions, no, it is not easiest, but the questions asked from this chapter are very, what you could say, solvable. So if you have the basic clarity, if you focus on the chapter, these questions are very, 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 very solvable. So there is not going to be a big deal, whereas you will have to face such kind of problem where it is not being able to solve or it is very difficult for practicing or something like that. No. So let's see, come to the next point. Let's see what do they have for us. Regression equations. Okay, so they have mean, they have standard deviation. Okay, let's solve example number 7 over here. After solving example number 7, I'll give you the properties of regression. See, let's understand what they have given. It is not necessary that you might understand this kind of question if many of you understand if you get what I'm trying to explain or the question becomes clear to you, then yeah, you are on the right track. The following data related to the mean and standard deviation. Following data related to mean and standard deviation of the price of the share of HDFC and ICICI in Nifty stock exchanges. So they have given us the mean and the standard deviation of the share. Okay. So there is a company HDFC, there is another company ICICI. So for the mean of the share value, the share values mean they have given us 44 and 58 for HDFC and ICICI respectively. And they have given a standard deviation. So let's assume HDFC to be X and ICICI to be Y. So they have given us X bar, mean means X bar. So they have given us X bar to be 44. They have given a standard deviation of X to be 5.6. They have given us Y bar is 58 and standard deviation of Y to be 6.30. So these are the things that they have given us. Now they are asking that the coefficient of correlation between the share price. What do you mean by coefficient of correlation? You mean it to be R. So they have given us R as well. They have given us R to be 0.48. Find the most likely price of share HDFC. Find most likely price of share of HDFC. So my HDFC is what? X. Corresponding to the price of rupees 70 of share ICICI. That means what does this part mean? This means I have to find HDFC's price when they have given us price of ICICI. That means I need to find X when they have given Y. That means I need to find X on Y. That is BXY. So let's see first the given data. I'll write the data over here, everything at one place. It is very easy. Just keep your eye open. Try to understand what I'm explaining. So first, I am going to find BYX. How do we find BYX? BYX is going to be R into standard deviation of Y upon standard deviation of X. So my R is 0.48. Standard deviation of Y is 6.30 upon standard deviation of X is 5.6. So when we solve this, this is going to be 6.30 divided by 5.6 into 0.48. This is going to be what? This is going to be your 0.54. This is going to be 0.54. Now when I am solving from BXY, my BXY is going to be R into standard deviation of X upon standard deviation of Y. 0.48 again, standard deviation of Y is X is 5.6 and standard deviation of X is 6.3. So 5.6 divided by 6.3 into 0.48, it is going to be 0.4266. Now what do we have? We have BYX and we have BXY. Now you have to understand one thing. They are asking us to prepare an equation because I need to substitute ICICI's share value and then find out in respect with the ICICI's share, I need to find HDFC's value. So when I'm talking about this kind of question, it is going to be X minus X bar. When I need to find what X, I'm going to use X minus X bar is equals to BXY into Y minus Y bar. Because this is what? This is X on Y's equation. I need to find X's value when they have given us Y's value. So my X bar, if you see, they have given us X bar. They have given us X bar's value. How much is the X bar's value? X bar is 44. What do we calculated BXY? The calculation of BXY was 0.4266. Y minus, what is Y bar's value? 58. Now when you solve this, you want what? You want X's value. When they have provided you the Y's value, they have told you that the share of ICI is 70. So we are going to substitute in the Y's value. So this is going to be X minus 44 is equals to 0.4266 into 70 minus 58. So this is going to be 70 minus 58 into 0.4266. This is going to be 5.111. So X is going to be 5.11992, and this is going to be minus 44 will go that side and become plus 44. So if we add 44 in this, this is going to be, my X's value is going to be 49.12. So when your share price, when the share price of Y, that is ICICI, is 70, at that time my HDFC's value is going to be 49.12. My HDFC's value is going to be what? 49.12. Now and also the most likely price of share of ICICI. And now they are asking us the price of ICICI when they have given us what? When they have given us the price of HDFC. And now I'm going to need a regression equation for Y on X. And this is going to be Y minus Y bar is equals to BYX into X minus X bar. I don't have y, but I have y bar 58. I have byx values. Byx value is 0.54. I have x's value. X's value they have given me 60. Minus x bar is what? X bar is 44. Now let's solve this. It's going to be 60 minus 44 into 0.54. It is going to be 8.64. So y is equals to 8.64, and this 58 would go that side. For addition plus 58, it is going to be y is 66.64. Y is going to be 66.64. So your x's value is 49.12, your y's value is 66.4. And so this is the way to solve by finding out what? By finding out the regression equation. By finding out what? By finding out the regression equation. So when we have the regression equation, we can substitute one of the value of x and then calculate the value of y and further all the other things. So yeah, we have seen many things in the correlation in this lecture. We have seen regression. There are two types of equation. One is going to be y on x. We are going to use y on x to find y. There is x on y. We are going to use x on y to find x. So this is the standard form of your regression equation. That is y minus y bar is equals to byx, x minus x bar. And other is going to be x minus x bar is equals to bxy into y minus y bar. Then we have y is equals to a plus bx, y is going to be independent, x is going to be independent, b over there is going to be the slope, a and b are going to be the constants. So these are all the things. Now we saw regression coefficient, that is bxy and byx. There are total 5 formulas for finding byx and 5 formulas for bxy, but there are only 2 formulas that are the most important, that is going to be r into standard deviation of y upon standard deviation of x, and covariance of xy upon standard deviation of x square in case of byx. And now you have got an idea that the formula is not changing. The formula is only going to be changed. The only denominator is being changed. The last number, the x, if you see, every time the last number is the denominator. Every time the last number in byx, x. So every time in the formula, your denominator is going to be of x. So these are the formulas we saw, and then we saw many examples. We saw many examples for finding out byx and bxy. And this was the type 2 we saw over here. In the next lecture, what are we going to do? In the next lecture, we are going to study some properties of regression, and then again let's then jump back to the other types as well, other formulas as well. Okay, so there are total, if you see, after completing type 2, we are going to see some properties, and after the properties I have how many types do we have? We have almost 8 types and then a standard error. So in the next lecture we'll finish off all the types over here, and then in the next lecture after completing, I'll need one more lecture for all the concepts and all complete all the other types. After that lecture, we will be solving the MCQs for your regression, and the regression topic will also be over there. And yes, so see you in the next lecture. Till then, keep studying. Bye bye. And yes, don't forget to share with all your friends that Akash Agarwal Classes is providing you with 100% recordings in English. Do share the video with all your friends, and yes, do let me know in the comment section how do you find the lecture. Was it helpful for you? Are the lectures helping? So yes, do comment in the do share a comment, do share a review in the comment box, because it is going to act as a motivation for us. It is going to guide, it is going to give more energy to record this kind of lectures, to record the strategy videos in English. So yes, do comment on the videos. Till then, keep studying. Bye bye. See you in the next lecture.